Looking to learn a little bit more about cylinders and how to calculate their volume? If that's the case, welcome to Math Tutorials 82, where we master together the skills that will set you up for success. There are a lot of generic shapes, such as cubes, rectangular prisms, triangular prisms, equilateral pyramids, torus, spheres, amongst others. These shapes already come with a predetermined equation to allow us to calculate their volume. In this lesson, we will focus on cylinders. So you might be asking yourself, what's the equation of a cylinder? Well, a cylinder has the following equation. You first have to calculate the base of the cylinder, which is a circle. And so we know that the area of a circle is pi times the radius of the circle squared. And so the volume is just taking that radius and multiplying it by height. So our final equation for the volume of a cylinder is the height times pi times the radius of the circle squared. So where can we find cylinders in real life? Well, gas cylinders, tanks, pipes, amongst others. And so your question is if we have a generic 10-foot pipe, how can we calculate the volume? Well, a pipe is a little bit different from a cylinder, but it's very similar as well. Because with a pipe, it's not just a one-stop shop. You have your inner diameter, your outer diameter, and your length. And so when we're calculating the volume, what we're interested in is this cylinder that's found in the inside of the pipe. And so our first demonstration will consist of finding the volume of the inner cylinder found in a generic 10-foot plastic pipe. This demonstration will cover how to calculate the volume for a single 10-foot piece of plastic pipe. So let's start. So what's the length of this pipe? It's 10 feet. And what does the ID stand for? That's inner diameter. And what does the OD stand for? Outer diameter. So we know that the area of a circle is equal to pi r squared, where r is the radius of the circle, which is shown right here. And we know that the diameter is equal to two times the radius. So we have d halves equals r. So if we do the conversion right here, it will be pi times d squared over 4. So to get the volume of the pipe, of the inner diameter of the pipe, you have P d squared 4 times L, and L is equal to the length of the pipe. So then, volume is equal to P inner diameter squared over 4 times L, which is 10, so becomes 5, this becomes 2, equals 5 pi over 2 times the inner diameter squared. So if you enjoyed that demonstration, you get 1 gold star. Now the next question is, in normal pipe installations, you have certain connectors that connect different types of pipe. These are the equivalent of 1/4 of the volume of a torus if the pipe presents a 90-degree angle. So, what is the volume of a torus? Well, the demonstration that I'm going to make will be how to determine the volume of a torus. So now we're going to be calculating the volume of a torus. So that is basically this donut right here. So we know that this has a radius of capital R. And we know within the torus we have a circle which has a radius R. So we know that the area of a circle is equal to pi R squared, where R is the radius of the circle in the torus. So we also know that the circumference of a circle equals 2 pi R. In this case, since we have the capital R. So the volume of a torus is going to be equal to circumference of the torus times, or we'll do a dot, the area of a circle. So that would be 2 pi R times pi R squared. That equals 2 pi squared R times R squared. Well, if you like that demonstration, you get 2 gold stars. So now we are going to do a demonstration of a real life case of calculating volume. So what do I mean by that? So we're going to take a pipe installation with a water tank and calculate the volume. So it's basically going to be this pipe that goes through the wall, goes up to the ceiling, goes around and connects to a water tank. So that's going to be the next demonstration. So demonstration of a calculating the volume of a pipe connected to a water tank. Let me make this a little bit bigger so you can see it. There we go. So we're going to do the demonstration where we're going to be calculating the volume of this pipe system with the water tank. And so with the pipe system, I'm referring to this pipe A, B, C, D, E, this water tank connector, and the water tank. So we have that pipe A is 1 foot, pipe B is 12 feet, pipe C is 20 feet, pipe D is 20 feet, pipe E is 12 feet. We have that the height of the water tank connector is 3 inches. The radius is 1 inch. The water tank height is 24 inches. And the water tank radius is equal to 6 inches. So we know that 12 inches equals 1 foot. And we know that the volume of a cylinder is equal to pi r squared times height. And we also know that the volume of a pipe is equal to pi r squared times the length, or pi d squared 4 times the length, which is also pi inner diameter squared divided by 4 times the length. Since we have a 1 inch pipe, we're going to have to calculate the following. So the total volume for this system is the volume of the water tank plus the volume of the pipe, which is pipe A, B, C, D, and E, plus the volume of the torus. And so where is this torus? We have 1/4 of the torus right here, another fourth right here, another fourth right here, and another fourth right here. So we have a full torus. And for the volume of a torus, we know that that is 2πr, which is the circumference of the torus, times the area of the circle inside of the torus, which is equal to 2 pi squared r times r squared. And so we have this r, which would be 1.029 inches divided by half, which is equal to 0.051 inches. And that divided by 12 is equal to 0.04 feet. So now let's calculate the volume of the pipe. So we have the volume of the pipe for pipe A, B, C, D, and E is equal to pi 1.029 inches squared divided by 4 times the length, which is 1 foot by 12 feet by 20 feet, 20 feet plus 12 feet. And that's equal to pi 1.029 inches squared times 65 divided by 4. And this is all equal to 22 over 7 times 4. And we have that 1.029 inches divided by 12 inches times 1 foot. Let's take this inches. That equals 0.09 feet. So we have 0.09 feet squared times 65, and that's equal to 0.41 feet cubed. So now, let's put this up here. The volume of the water tank is equal to volume of the water tank plus the volume of the water tank connector. And that's equal to pi r squared times h. Let's do a h right here. So this is h and this is h plus pi r squared times h. And that's equal to pi. And this is pi r squared prime. R squared is 6 inches squared times 24 inches plus 1 inch squared times 3 inches. So that equals to pi 867 inches cubed. So we divide that by 12 times 12 times 12 inches cubed in order to get feet cubed. And that's equal to 1.58 feet cubed. Now we have the volume of a torus. So the diameter, so for the torus, we have 2 pi squared times 0.04 feet squared times r. So that would be 2 times that would be roughly 0.03 feet squared times r. And so r, we're going to make the assumption that because it's a connector that looks like this, we know that this is 0.04 feet. And so we're going to make the following assumption. We're going to say that the distance between here and here, and here are the same. So we're going to say that R equals to R, just to make that assumption. And so 0.03 times 0.04 equals 12 feet cubed. So for our final amount, that's 1.58 feet cubed plus 0.41 feet cubed plus 0.0012 feet cubed, and that's equal to roughly 1.99 feet cubed. So that would be all the water that's going through the pipe and into the water tank. So it would be a completely filled system. That would be the total volume. If you like that demonstration, you get 3 gold stars. So I hope you've learned a little bit more about both the application of cylinders, how to calculate their volume, where we can find them in real life, and in case you have a pipe installation in your house, apartment, place of work, you know how to calculate the volume of the liquid that's going to go in there. Very possibly water, but could be mistaken. Please check out the videos I linked in the description, and don't forget to subscribe. I guess I'll see you in the next one.